Hello, 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 hello. Am I audible and visible to all of you? Hello, beta. Hello. So I guess my voice is fully audible, right? And I guess my video is also visible. So as you can see now in my background, we are going to start the next chapter, that is current electricity. After the current electricity, we will start a capacitor one. Okay. So we had concluded the first unit, that is electrostatic, in which we discussed about uh, electric charges, field, electric potential. These things we discussed in the last few lectures. Okay, and if you want to get very great understanding of the further chapters, you need to just complete your previous one firstly. Okay, which we discussed about electric charges, electric potential. Discussed the last lectures. One second, one second, one second. Okay. So then let's start the new one. Okay. So hello, Sumara. Okay. So before starting this chapter, now do one thing: just complete the backlogs. Okay. And with the backlogs, complete this one parallelly to that, right? So that next backlog won't be get piled up. Okay. So let's start now with the very first lecture of current electricity. We will be starting from very basics. Okay. We will be doing basics, the definitional part, the derivation part, and then NEET and JEE part. Okay. So if you find any difficulty, you can just let me know. Let's start now. Okay. Look now. So the name of the current chapter is, it is current electricity. Okay, it is current electricity. Current electricity. So basically in this particular chapter, we need to study about electric current. What basically is electric current, how electric current gets created, okay, how to find the direction of current, and how to calculate the current and charges. All these things we need to discuss in this particular chapter. Let us suppose we have a conductor. Let us suppose we have a conductor. Okay, this is conductor, or simply a wire. Okay, I will write it is a conductor of wire. Conductor. And you know that in conductor what we have free electrons. What we have? We have free electrons or free charges. It is free charges. What we have? We have free charges. And suppose the cross sectional area. Suppose the cross sectional area, this area, na, the white one. The area is suppose A. Suppose the area is A. Area is A. Okay, this area, no? And we have Q charge, right? We have Q charge. What is this Q? Sir, Q is charge. Q is charge. This charge is flowing. That means it will cross this particular area. This is my area cross section. The charged particle is crossing this area, no? My charged particle is crossing the area. My charged particle is crossing this area. So when the charged particle is crossing the area in some time interval t, let us suppose in some time t, in 1 millisecond, 1 microsecond, 1 nanosecond, the charged particle is flowing through this area, due to which something will happen there. When charged particle is flowing in a time interval, something gets produced. That something is known as current. That something is known as current. So what is current here? Sir, we can write it is a rate of flow of charge. What we can write? It is the rate of flow of charge. A rate of flow of charge through any cross-sectional area. Through any cross-sectional area. That means we are not confined to any area. We can take the area as 1 meter square also. We can take it 1 micrometer square also, right? Any area. Hello, beta. We can take any area. Any area. Let's suppose we have a small area. We have this big area. In both the cases, if charged particle is flowing in some time interval t, something will happen there. Something will get created. Nah, that something is known as current. So by this definition, I can write current. I can write current. Current is equals to flow of charge. It is what? It is flow of charge per time. Okay, so I can write current as I, charge as Q, time as T. So now by this equation, we got to know how to get my current. So current is equals to Q by T. It's Q by T. Very easy. It's very easy, no? Okay. So now, if we talk about the unit, sir, how to calculate the magnitude of current? How to get this value? Look now here. I guess Q is charge. Charge we can calculate it coulombs. We can calculate it as coulombs upon time in seconds. It is coulomb. It is coulomb per second. And this thing is also known as ampere. This thing is also known as ampere. Ampere. That means the SI unit of current is what? It is ampere. It is ampere. Now you will get the question in your school examination, not in NEET and JEE, in school examination. Define 1 ampere. Okay, sir, how to write now 1 ampere? Look, if in school you will get a numerical, define 1 ampere. Okay, 1 ampere. I guess 1 ampere means if 1 coulomb charge is flowing through any cross-sectional area in 1 second. Okay, if 1 coulomb of charge is flowing through any cross-sectional area in 1 second, so I will say that 1 ampere current is there. Very easy. At most easy thing. Done. Now, which quantity current is? So current is a scalar quantity. So current is what? Current is a scalar quantity. Current is a scalar quantity. Done? Current is a scalar quantity. Sir, how current is scalar quantity? You might get this thing in your head, na, sir. Current is having direction na, through the wire, and it is also having the magnitude. Why then it is a scalar quantity? It is, the cause is very big, na. But here in a shortcut way, I will just make you understand why it is a scalar quantity, na. The reason for it in a shortcut way. Okay, the reason for it. A reason. Look now. Look, 1 ampere current is coming. 1 ampere current is coming. So through this one, how much current will flow? So 2 ampere. Okay. If this angle is 60 degree. One more example. If let's suppose here angle is 90 degree. 1 ampere, 1 ampere. You will get same 2 ampere. That means if we are changing the angle between, the wires, nothing changes. 2 ampere, same 2 ampere. That means it doesn't follow the vector addition law. No, we know the vector addition law. A square plus b square plus 2ac cos theta. It depends on theta also, right? So that's why current is a scalar quantity. Why, sir? Because it doesn't follow. It not following. It is not following vector addition. Okay. If it does so, then there might be change, na? Look, we are changing the angle, but still my result is same, 2 ampere and 2 ampere. Very easy, na? That's why current is a scalar quantity. I guess you got it, no? To this point, very easy now. Okay, now if we need to get the dimensional formula of it, if we need to get the dimensional formula of current, dimensional formula, I guess current is ampere, no? A. So dimensional formula is A only. Or I can write, sir, M0, L0, T0, A1. Dimensional formula of current. Dimensional formula of current. Now, if we talk about the direction, no, if we talk about the direction, this one is very good thing. Direction property. Direction. Look now. If we have positive charge, second case, if we have negative charge. Okay. If positive charge is going in this way, and if negative charge is going in this way, okay, so in the direction of flow of positive charge, the direction of current is same, so I will be in this way. But in case of negative, the current will be the opposite to the flow of charge, I. Got it? If positive charge is going from left to right, the current caused by the positive charge is also from left to right. But in negative charge, if charged particle flow from left to right, the current caused by the flow of this negative charge will be from right to left. This thing you have to keep in mind, na? Positive, negative thing, okay? So in the direction of positive charge, current is same as that of the positive one. But in case of negative, the direction of flow of negative and the direction of current will be the opposite. You need to keep this thing in your mind, na? Direction of current. Okay? Easy, na? If you have any doubt, you can just ask me in the comment box, na? Now, if we talk about the types of current, if we broadly divide the current, we have two types. We have two types. One current is average current. One is average current. One is instantaneous current. Instantaneous current. Okay. Now, sir, what is the difference between average and instantaneous current? Let us suppose charge is flowing through the conductor. Charge is flowing through the conductor. And I will ask you, find the current at t equals to 2 seconds. That means exactly when the time is 2 seconds, you need to find the current. Second statement. Current is flowing through the conductor. And I will ask you, find the current. Find the current in the time interval of 0 to 4 seconds. That means in 4 seconds, you need to calculate current. Second one, at 2 seconds, at a particular time interval, you need to find something. Same with the case of average speed or instantaneous speed. Okay. Average means in a broader interval of time. And the instantaneous means at a particular time interval. Okay. You will get this thing done now. After we will do some sort of numerical analysis of it. Okay. Average means in a very time interval from 0 to 4 seconds, 2 to 10 seconds, 2 to 10 seconds. It is not at a specific time. But instantaneous means at a particular time. At a particular time. Okay. So I will write here, sir, average current is how much? It is delta Q by delta T. Clear? And instantaneous, I will write it as a, sir, it is dq by dt. These are the notations to represent average current and instantaneous current. Now, so I can write instantaneous current, inst. It is instantaneous current. I can get it when I put limit delta t tends to 0, delta q by delta t. It came out to be dq by dt. A very sophisticated way to represent this thing, no? When we are putting delta t. Look, delta t tends to 0 means it's very small interval of time, very small. Okay? Easy? Let us just define these things. No? Look now. Look better. What is the usage of it now? Sir, why we need to find delta q or these things? What is the usage of it? Look now. Look now. Look now. What equation we got here now? Sir, we got here current I is equals to dq by dt. I guess I can write like this now. dq is equals to idt. Something like this we can write. If I integrate it, let's suppose I will integrate it. I will integrate it. So the integration of dq would be delta q. Done. Integrate idt. Let us suppose I will integrate this thing between time interval t1, t2. T1, T2. Something like this. Okay. So this thing represents area under curve. What is this thing? Sir, area under curve. Area under curve. This one is for NEET, no? Just and JEE. Area under curve. That means if current and time graph is given, the area under time current time graph will give you the charge. Sir, how? Look, Look beta, if we have something like this, look now, my time, current, and some graph is given in this way. Look now, in this way. This initial is T1, this one is T2. I need to get its area. Look, now it is very complicated, so we don't get its area directly by using any equation, by using any formula, trapezium or any formula. Now, anyone we cannot get it now. So how we can get it now? I will take a very small strip of this one, small strip, small one, this one. So I will write, sir, the width of this one would be dt. It is dt, and look here, its value would be, let's suppose, I. So what is the area of this strip? Area of this strip, I will write area of strip. Area of strip, no? I can write it, sir, it is length into breadth. So can I write I dt? It is I dt, no? Okay. So I can do one more thing now. I will divide here one more strip. Here one more strip. Same way I will take here one more strip. Here one more strip. Then I need to add them all. So add means I will take the integration. From where? So I need to add from T1 to T2. So I will add it from T1 to T2. Okay. So I will get the area of this curve. Area of this one, no? I will get the area, no? This area. I will get this area. Okay. This area. And this particular area gives me what? It gives me the charge. So I will get this is what? Charge. So area under current time graph or curve will give me the charge. You need to understand this point, no? So area under strip will give me what? Area under strip will give me charge. Very easy. Now, okay, let us take some different example. Okay, let's take a hydrogen example, hydrogen atom example. Okay, in the class, no? In very short time interval, I'm just taking a varieties of numericals. Okay, I'm just taking the varieties of numericals so that you will get better understanding of the chapter. No? Look now. Suppose how to deal with different types of numericals. If we have a hydrogen atom, let us talk about the hydrogen atom. Hydrogen atom. Okay. I guess in hydrogen atom we only have one electron. Okay. So I will write here number of electron is one only. So it would be spherical, not the Bohr atom like that. So here center. So here I will be having my electron. And this electron is revolving around it with some speed v. Done. Radius of this orbit would be r. So if my charged particle is traveling, that means there would be a current. So in hydrogen atom, na, find the current. Okay, how you need to relate it? Charge electron is also charged. Electron is flowing, it is traveling. If charged particle is flowing, so it will give me the current. So here charge is flowing, so it will give me the current. We need to find the current value. Sir, how to get it? Look now. By simple equation, sir, my current equation is equals to charge by time. It is charge by time. Charge is how much? Electron E. Time is T. I guess from the mechanics we know. So what we know? Speed is equals to, I will write speed equals to distance by time. Speed equals to distance by time. Speed is v, distance is how much? 2 pi r. 2 pi r, circumference of the circle divided by time t. So therefore, time I can write it as a 2 pi r divided by v. So I can write E into v divided by 2 pi r. This is what? This is the value of current flowing in a Bohr's atom, the hydrogen atom. Let us suppose we need to find the current in terms of frequency. Suppose we need to find this current. Okay, let's suppose in any numerical, if frequency is given and charge is given, how to find the current now? One thing now, do you know what is the frequency? Do you know what is frequency? I guess frequency is equal to 1 by time. 1 by time is frequency. So can I write now by using this one? Can I write now, sir, I is equals to Q, and I will take 1 by T differently now by using this equation. Yes, sir. So I equals to Q. I guess 1 by T is frequency. So one more equation for current calculation is current is equals to charge into frequency. Current is equals to charge into frequency. These are some points for your complete examination. Now, beta, these are some points for your complete examination. And I am giving you to the point things, right? I am not just keeping in around the bush, and at the end I'm telling you, no, this is something. I'm giving a straightforward answer. How to get these things done, okay? And you need to maintain a separate short notes copy. Just write these formulas. Look now, one more important thing. Let us suppose look, in the back classes that means in 10th class, we had studied about if the charged particle is flown, but there we only considered the electron only. We only considered the electron. Suppose the electron is flowing and we need to find the current. But in 12th standard or in NEET or JEE, let us suppose positive ions and negative ions both are flowing. Positive ions and negative ions both are flowing. Then we need to find out what is the net charge. Suppose I will make you understand by taking an example. This is my some sort of conductor. It's my conductor. So I am in class 10th. I don't know why I am here. But how do I know? How do I know? I'm just teaching my stuff. You come to my class, okay? And it is your will to be in the class to get something. So in 10th also, if you want your foundation to be good, you can just take my class. And one more thing that in coming days, I'm launching my 9th, 10th class also, right? The foundation, NEET and JEE classes. Not only for board, foundation and foundation, NEET and JEE classes. So in coming days, I will be launching 9th, 10th, 11th also. So 12th, I'm just teaching right now, okay? But my 9th, 10th would be, it is not for boards only, it will be for your complete examination level. And due to some weather conditions here, The network gets very slow. So I guess I need to wait for 1 minute to get it good. So right now, due to some time constraint, I only have 2 hours just free in a day. So I'm just dedicating 2 hours to teach the eligible student. Now in coming days, sure, I will be teaching. I will be having more time free, so I will be teaching the different classes as well. So don't worry, Just keep this in your mind, Don't worry about it. Nothing, Don't worry about it. Okay, you can just take those points, which are relevant to you. So you don't know vector, Just keep this thing inside, You will get something new here. Let's suppose here, look now. If we have both positive ions and negative ions, look now. These are my positive charges, positive, and these are flowing from left to right. My positive charges are flowing from left to right. And we have a negative ions also. Negative ions. Negatives are going from right to left. So now you need to find the current. You need to find the current. In the previous example, now you can see here. You can see here, right? Look now, this one. If positive is going in left to right, current will flow from left to right. That means in the direction of positive charge, current will be the same direction. But it will be opposite in my negative charges. Look now here. Sir, due to these positive charge, if these positive charges are flowing, so my current, that is what I current 1, current I1 will be flowing from left to right. Now, this one, my negative charge is flowing to right to left, due to which my current I2, it will flow from left to right in opposite. So therefore, if you need to write I net current, I guess net current would be I1 plus I2. Why? Because both current flow in the same direction. Look, same direction. Both current is flowing in the same direction. I don't know why that happens to my this network, every time when I'm just teaching something good, every time it just. So look now, but in some cases, we need to apply the mole concept also. Back in electrostatic, we had some numericals based on the mole concept. Here in electric current also, we had some numericals based on mole concept. So let us know how to deal with the mole concept. Okay, let us deal with the mole concept part. Let us merge chemistry with the physics. How to get it? Look now. I'm giving the way now to deal with the mole concept. Mole concept. In Kashmiri, mole means father. Mole concept. Okay. So N means number of moles. It is equals to mass divided by molar mass. Mass divided by the molar mass, which is equals to number of atoms. Number of atoms divided by the Avogadro number. Okay, this equation you need to keep in your mind. Number of atoms N, mass by molar mass equals to number of atoms divided by Avogadro number, Na. So what we can do here now with it, what we can do now? Let us take some numericals now, due to which the previous concepts we will get a very good grip on that. How we can do it? Look now. Look now. First numerical. First numerical of our electric current. The number of electrons flowing per second. Number of electrons flowing per second through any cross section of wire if it carries a current of 1 ampere. How to deal with these sort of numericals? What we need to find out? Okay, what basically we need to find? One second. Why my network is so weak here? It is very weak. How to do it? One second. Okay, so we need to find the number of electrons flowing per second. Number of electrons flowing per second. So I guess I can write current. The basic equation is current. Current is equals to charge per unit time. And by the equation from the quantization, charge is equals to number of charged particles into charge of electron divided by T. Clear? So current is given 1 ampere. Okay, sir, current is 1 ampere. And is and we need to find out E is 1.6 is 10 to power minus 19 coulomb. T is per second, that is 1. So I guess N is equals to 1 divided by 1.6 is 10 to power minus 19 coulomb. It came out to be 6.25 10 to power 18 charges. Done? So this is how we can manipulate our question. No? The same question we done in quantization numerical back in our electrostatic. How many charge particles are present in 1 coulomb of charge? Okay, same. Sir, in 1 coulomb, 6.25 10 to the power 18 electrons are present. Okay. Look now. One more numerical, a good one. Now we have a very good numerical. Numerical is we have 10,000 alpha particles. 10,000 alpha particles pass per minute. Pass per minute through a straight tube of a radius r. What is the resulting electric current? So we need to apply here couple of things, right? Also, look, here we have 10,000 alpha particles, and we know that alpha particles, okay, alpha particles means He plus plus. That means in helium atom, if we extract both the electrons, we will get a helium 2 positive, or okay, and that helium 2 positive known as alpha particle. If we need to write the charge, so charge of alpha particle is 2 times charge of proton or electron. How we can write it? Okay, look now. So what is current? Sir, current is equal to charge per unit time. What is Q? Sir, Q is equal to N times E, or N times charge of electron, QE, right? Divided by T. So here we are not talking electron, we are talking about what? Alpha particle. I can write N. Alpha. Alpha is 2 times charge of proton or electron divided by T. Okay. N is 10,000 multiplied by 2. Charge of proton is 1.6 10 to power minus 19. Whole divided by T. T is what? T is per minute. Per minute means 60 seconds. Per minute means 60 seconds. Okay. So T is how much? 60 seconds. So I came out to be, look now, I came out to be, look, 1 0 cancel out, 1 2 3 3 0 and 19 3 zeros, it is 16. So I can write 3.2 divided by 6 multiplied by 10 to power minus 19 plus 123. Done. I can write here 3.2, so 0 cancel out, so here I will write to multiply by 0. This 0 came out to be minus 1 here. So it is 32 by 6. It came out to be 5.3. It is 5.3 10 to power minus 17 ampere. Okay. So you have to manipulate your numerical like this, no? Definitely, no? In coming days or in coming, yeah, in coming weeks. So I need to just, we are having some sort of issue right now. Some medical things are going on. So after everything gets settled, na, so I will be just launching a course of foundation 9th and 10th also. Okay, don't worry about it. I guess my network is getting worse and worse, right? So we don't need to do it. So no issue now. My voice is going in a lag way now, but my video is still in a good thing, right? Okay, one more numerical. One more numerical. Numerical is like my charge Q is given to be, it is 1.5 T square plus T. Okay, so I need to find out current. Give me current at T equals to 2 seconds. Okay, now we have two formulas. In the previous slide, we discussed two formulas. Current, either I can write current as a delta Q by delta T, or I can write as a dQ by dt. This one means average. This one means instantaneous. Okay. Instantaneous means at a particular instant of time. Average means in a very interval of time. Now here it is t equals to 2 seconds. That means exactly at 2 seconds I need to find the current. I guess exactly at 2 seconds refer to the instantaneous value. Yes, sir. Okay. So I can write current I is equals to, it is dq by dt. I can write d by dt. What is q? So q is equals to 1.5 t square plus t. Okay. So what is the differentiation of this one? So as we know that differentiation x to power n is equals to nx n minus 1. So here 1.5, I can write 1.5 is constant. I will write 2t 2 minus 1 plus differentiation of t would be 1 only. So I guess I will write here 2 5s are 10, 2 it is 3, 3 it is t plus 1. It is current. Now current came out to be 3t plus 1. But I need at 2. So I will put t as 2. So it is 3 into 2 plus 1. It will be 7 ampere. 7 ampere. But I am not an IITN, I am an NITN, right? It is NITN. Okay. Done. Very easy, no? So by this one, you will find where you need to put the instantaneous value. Now, one numerical by which you will get an idea where you need to put the average value. If my current is given as Q is equals to 8t minus 2t square, I need to find current. Give me the value of current. And my time intervals are given from 0 to 2 seconds. Look here, time interval is given. If time interval is given, so I need to find the average current. I need to find the average current. Okay, so how to get my average current? How to get my average current? I guess my average current, I average is equals to delta Q by delta T. Delta means change. It is final charge minus initial charge divided by final time minus initial time. Okay, so look, Q final we don't know, Q initial we don't know, final time is 2 seconds, initial is 0. Now this one is final time, T final, this was his initial time. Now what is Q final? Q final means, Q initial means, so I can write 8 into 0 minus 2 into 0 square. I guess my answer is 0. Finally, it is 8 into 2 minus 2 into 2 square. 8 2s are 16 minus 2 2s are 4 2s are 8. My answer is 8. So can I write now my average current is equals to 8 minus 0 by 2 minus 0, which is equals to 8 by 2, that is 4 ampere. So my current came out to be 4 ampere. My current came out to be 4 ampere. So by this numerical, you come to know that where you need to fill or apply the average value and where you need to apply the instantaneous value. Done. So we concluded some examples in which we find the average current, instantaneous current, these things we conclude. No? Let us do a numerical in which we will find the charge. Or we find a charge now. Okay. Look how to get the charge thing done. Okay. One more question, and that is, my equation of current is given to be, it is 2t plus 3t square. That means current is time varying. Time is given. Time interval is given to as 2. Initial time is 2 seconds. Final time is how much? 3 seconds. So during 2 to 3 seconds, charge particle flow through the conductor. We need to find the charge. We need to find the charge. So how we can get a charge? I guess to get the charge, we need to apply the formula that we done in the past. Now that is, look, delta Q is equals to integrate from T1 to T2. It is I dt. Yes, sir. So now integrate. Initial time is 2, final time is 3. I is given to be 2t plus 3t square with respect to dt. Okay, sir. So integration of 2t with respect to dt. Look, 2 is constant, I will take it outside. Integration of t dt. Okay. I guess t is 2 square by 2. It is integration of what? The 2t. 2 cancel out, it is t square only. So can I write here integration from 2 to 3, integration of 2t is only equals to t square plus. Now 3t square, 3 integration of 3t square dt. 3 I will take outside, integration of t square dt. Okay. 3 integration of t square will be t cube by 3. 3 cancel out, it is t cube only. So I will write t cube only. So I don't need to write the integration sign now because I had done this one. Upper limit is 3, lower is 0. So I can write delta q equals to upper limit is 3. It is 3 square plus 3 power 3 minus 0 square minus 0 power 3. 3 3 are 9, 27. Delta q. I guess it is how much? Well, it is not 0 now. I am just placing here 0. It is not 0. It's 2 square 2 cube. That means 4, 8. So now it is 9 plus 27, 36 minus 12. So my answer is 24 coulomb. My answer is 24 coulomb. Okay, this is how we can do these things now. Okay, let us do a numerical based on the hydrogen concept. Let us do a numerical based on hydrogen concept. And the question is, we had the hydrogen atom and my radius is given. Radius is 5 into 10 to power minus 11 meter. Speed is given as 2.2 10 to power 6 meters per second. I need to find the current. So it is given now for the hydrogen, it is given to us. So I guess my equation was equals to current is equals to how much? Charge into speed divided by 2 pi r. What is E? 1.6 10 to power minus 19 multiplied by what is V? V is 2.2 10 to power 6. 2 is 2. What is pi? Pi is 22 by 7. R is 5 into 10 to power minus 11. Cancel out 0. So here I will write 10. 22, 22 cancel out. Okay. So what I can write here now? Look, I came out to be this into 0 came out here. So what we have here? It is 16 into 5 into 7 into 10 to power minus 19 plus 6 plus 11 minus 2. 16 into 7 is 16, no? Yeah, 2 on the 2 towards the 16. Yeah, I can do one more thing, no? Not just cut it. It is 16 into 7, no? Okay. It is here 5 to the 10. So this 10 cancel out. So I need to write here minus 1 also. 16 into 7 into 10 to power 19 minus 22 plus 17. I guess my answer came out to be how much? It is 1670. It is 1112. So it is 5. 5. Yeah, I can write it 1.12 now. 1.12 milliampere. Just check it now. I guess this answer is correct. Okay. 5. Yes. Yes, this is correct, no? This one is correct. I guess I am just lagging somewhere, no? I guess no, this is 16. 1 second, beta. Correct? Okay. One more numerical. Okay. More numerical. Numerical is like we have a neon discharge tube. What do we have? A neon discharge tube. We have Ne plus. These are cations. How much? 2.9 10 to power 18 Ne positive, Neon positive are present. These are going in rightwards. This is the direction of it. Direction. It is direction of neon positive for each second. Now we are talking about each second. Now we have electrons. How much? 118 electrons. These are going to left per second. It is per second. Per second. Find the current. Look, if neon is going in this way, so current will be in this way. Current is electron is going in this way, so current will be in this way. I to I. So I guess I net. So I net is equals to I1 plus I2. What is current? It is charged by time. Q1 charged by time. Time is 1 second, so I can write Q1 plus Q2. What is Q1? It is number of, it is N and charge, no? Ne, yeah, plus N2 E2. Done? So I can write I net. Look, charge is same. I will take E same. Then I have N1 plus N2. What is E? 1.6 10 to the power minus 19. N1 is 2.9 10 to the power 18. N2 is how much? 1.2 10 to the power 18. Look now. 1.6 10 to the power 19. I will take 18 common, 10 to the power 18. Internally, we have 2.9 plus 1.2. It is 1.6 10 to the power minus 1. It is 4.1. Done. So 1.6 into 4.1. I guess my answer is 0.65 something. It is 0.66 ampere. This one is my answer. This one is my answer. This much is my answer. Okay, let's do one last numerical. Okay, last numerical for today's class. Last numerical, and this numerical is very good. Okay, the star one. Okay, star one, and numerical will be like, I will write the full language of numerical. Find the number of free electrons. Find the number of free electrons per unit volume of a metallic wire of density 10 to the power 4 kilogram per meter cube. Atomic mass is 100. If the number of free electrons per atom is 1. How to get it? So what we need to find out? Number of free electrons per second. So I will write number of electrons per volume. I need to write volume. This thing I need to find out. So I guess mole concept, N equals to mass by molar mass. Mass by molar mass, which is equals to number of atoms divided by Avogadro's number. Number of atoms, so I can replace it with the number of electrons. So I can write number of electrons divided by Avogadro's number, mass by molar mass. Look now, so I can write number of electrons is equals to mass multiplied by Avogadro's number divided by molar mass. Number of electrons I will place here, so I can write number of electrons. It is mass into Avogadro's number whole divided by volume into molar mass. So mass per unit volume equals to density. So I will write here density into Avogadro number divided by molar mass. Okay, it is visible now. Okay, so this equation I will write here. So my density is given how much? 10 to power 4. It is 10 to power 4. Avogadro's number 6.023 10 to power 23 whole divided by molar mass is 100, but 100 molar mass is grams, so I need to convert it to kilograms, 10 to power minus 3. Okay, so look now, 203 I can write here, it is minus 1 then. Okay, or you will get confused. Now I will write this whole stuff, you will get confused then. You ask me, sir, how you have done this one, right? It is 100 10 to power minus 3. I will write it 6.023 10 to power 23 plus 4 whole divided by 10 to power 2 10 to power minus 3. I will write it 6.023 10 to power 27 divided by 10 to power 2 minus 3. So then I will write 6.023 10 to power 27, or this one 10 to power minus 1. It is 6.023 10 to power 28. This value is number of electrons per unit volume. So this is how we will manipulate our numerical based on the inputs. Done? This is how we will manipulate our numericals. I guess we had discussed a lot thing now. If you find any doubts in today's class, you can ask me now within 2 minutes. Then if not, then we will end our today's class. So tomorrow we will start lecture number 2. Tomorrow we will be discussing relaxation time, okay, then length, then drift velocity, current, if time permits, Ohm's law also. So today we will be doing something very important, okay, for your physics, how to get these things done. Drift velocity, all those things, thermal velocity, how to use the Boltzmann's constant there, 3 by 2 kT VRMS value. What is VRMS value? What is thermal speed of your electron, right? All these things we will do in the next class. Done now? At room temperature, what without putting the electric field, what will be the my electrons or charged particles velocity or the speed? These things we will discuss in tomorrow's class. For today, I guess we had discussed more than enough, and I would request you that you need to do couple of numericals by your own now. based on the things that we had discussed right now. So in today's class, we discussed about electric current, its equation, instantaneous, average, why we need to put instantaneous value, average value, how to get the electron thing done in atoms, how to find the frequency, how to use the mole concept. Okay, so these things will be done in today's class, and rest thing we will do in the tomorrow's class. If you have any sort of doubts or anything like that, you can just ask me, right? So for today, we had discussed more than enough. So bye from my end. Good night. Bye. Kimura, thank you. Bye. Thank you.